Hey guys, it's Bryce and Aaron.
And it's spring and we're starting to thaw out over here and we're bringing you some brand new stuff.
Let's start off with drawings. In the March update, we have some major enhancements to hit Fusion 360 drawings. First on the list is a highly requested feature on the Idea Station. Now in Fusion 360, we can create multi-sheet drawings. At the bottom of the drawings environment, we can see different sheets that pertain to this drawing. Let's add a new sheet to this drawing by clicking on the plus sign. Let's right-click this sheet and rename it. In addition, we can delete this sheet and output this specific sheet out as a PDF if we needed to get it to a customer quick. Notice in the title block, the sheet page and total pages will automatically update. So on this sheet, we want to start documenting the bottom plate. Let's place a view of the bottom view of this entire design. Once the view is placed, I get a browser on the left side, which is similar to the browser while designing in the model workspace. Here we get a checkbox to suppress and hide the part from the views referencing this design reference, or a light bulb to just hide the components in the views, but not suppress the components from things like a parts list. In this case, we just want to work on the bottom plate, so let's right-click on that component and select Suppress All Except Selected. Let's jump a bit ahead. Next, we want to start throwing some dimensions for the location of these holes. Now in Fusion 360, we can add ordinate dimensions. Let's start by defining the origin of the ordinate dimension. There's no sharp corner on this part since the corners were filleted. We can inference off these two edges to locate our ordinate dimension origin at the virtual sharp where these two edges would intersect. Then I could start clicking on different drawing entities to finish up these ordinate dimensions. The ordinate dimensions will automatically flip whether they're going horizontally or vertically from the origin point. Now let's move on to the next big enhancement. We can now create custom tables inside these drawings. Let's create a table and place it in the corner. We can add rows, columns if needed. We can populate the table manually. In this example, we created a hole table to call out the location and size of the holes in this part. Finally, let's jump back into some multi-sheet goodies. Last time when I added a sheet, I hit the plus button. When I do this, Fusion 360 will use the template from the active drawing sheet. This time, I will right-click and select Add Sheet. This will give me the option to select a different template. This sheet will be my cover sheet at the beginning of this drawing, so I can simply click and drag sheets to reorder them. Finally, it's a standard at my company to always have a drawing with the same 3 starting sheets. I can set up my drawing template to have as many sheets as I want with varying title blocks and sizes. I can now save this drawing with different sheets as a template. Next time when I create a drawing, I can select this as my template, and I will start with the different sheets with varying size and title blocks. These drawing enhancements are huge and further the ability to document our designs in Fusion 360 to meet our demanding needs of our customers, contractors, and manufacturers. Now let's move on to some of the enhancements to hit the sketch environment. First, the look at behavior has been improved while sketching. There's an option to look at the active sketch when it is created or edited. Make sure to activate this option in the Preferences under Design. Previously, the Look At option would fly the design off the screen depending on different scenarios. Now the design will stay on the screen and keep you from having to locate and pan your design back into the viewport. Next, we've added a horizontal and vertical flip option for the SVG import. Sometimes the SVG coming from an unknown source is inverted. Now in Fusion 360, we can control the direction of the imported SVG. Let's use the SVG preview to ensure the location and scale of this SVG is in the correct location. Now let's box select this imported sketch geometry. Notice that I am selecting a lot of geometry on purpose. Now Fusion 360 will only select sketch entities in the active sketch. Previously, we would be able to select sketches in geometry outside of the active sketch. With all of these sketch entities selected, I can turn this into an extrude. But first, I'll deselect a few sketch regions that I do not included in this cut extrude. This will ensure that we can box select sketch entities while in a sketch without having to play the hide show game when bodies and other sketches are visible. Now let's move on to some of the spline improvements. Previously, when a spline handle was dragged around, it would sometimes automatically grab a horizontal or vertical constraint. Now these constraints will not automatically get inferred, but you can still make the horizontal or vertical constraint manually by selecting the tangency handle and selecting the constraint. Next, when you select the spline, different handles pop up at spline fit points and endpoints. These handles control the tangency vector at that point. With these handles, you can control the magnitude, which is the length of the tangency handle, and the angle or direction it's facing. We can also activate the curvature handle at these points. This is similar to the tangency handles, but it controls the curvature rather than the tangency at that point. In this update, you can activate the curvature handle simply by right-clicking on the points. Now start controlling your splines like a pro. Now that's it for the sketch enhancements. Let's throw it to Aaron to talk about the gold nuggets in modeling and simulation.
Modeling saw a number of small updates, starting with a couple in the user interface. I'll direct your attention to the timeline control buttons, where you'll now find that the play button is no longer placed in between the step forward and fast forward buttons. Now it's in the middle, standardizing what every human since the dawn of mankind has come to expect. In addition, us Mac users will now find that when a compute all is initiated, we'll see a progress bar. This will reassure us that it is indeed computing and not sitting idle or frozen. As I move into adding to this design, you can see my bodies folder has become quite a mess. To help with the organization, I can now create groups within the bodies folder. I'll create two, one for pins and one for the belay bodies. These are just as easy to add to or edit. So in this case, where I added the carabiner pin to the new folder rather than the carabiner component, I can easily fix that. Speaking of folders, the decals folder has reappeared, making those appearance-enhancing images, icons, and stickers easier to manage and find. And managing appearance quality and texture orientation was improved drastically with the addition of some entirely new options and controls. For instance, if I don't care to see every intricate detail of the carabiner because I'm really working on the belay device, I can use the display detail control to fix the detail level at a low setting. Imagine how this can help reduce the hardware overhead of large assemblies, or, on the flip side, enhance the viewing quality, rendering, and anti-aliasing of simpler models. Let's do something to improve the already great appearance of the belay device. Let's adjust the texture map control so the brush grain is presented properly. Aiding in these efforts is a new texture map control display. UV diagnostic texture. This will reveal a grid and arrows in place of the texture, giving clear indication of the direction. A quick adjustment here, and we're ready to start making more renderings of this awesome design. Let's switch gears now to look at the new simulation functionality in this update. The first blaring change will come when I go to make a new study. The totally revamped study selection window makes it so much easier to understand what studies I have access to, and as I select each, details about what they do. Following what was described in the buckling study description, I'll select this slender member to try to understand if the compressive loads acting on it will cause buckling. The buckling study was set up in a GIF, and from there I moved on to a static study with bolts, which is also ready to run. So let's hit the Solve button where you'll see another update, this time related to the visibility of cloud credit use and availability. This mimics the appearance you'll find when cloud rendering. As was always the case, there is no cloud credit charge for jobs that fail, and the good news is that if or when these fail, the cause and recommended course correction is more clearly communicated in error messages, and expect further improvements in releases to come. While I was talking all about errors, a couple of my studies solved successfully, so let's start diving into those. The static study results start in the factor of safety plot, the new default plot type. Now we can quickly get an understanding of the performance of this design without needing to change plot types. A value this low is something I might want to address, but at the same rate this footrest isn't mission critical like the other pedals. One of the 3 shape optimizations I started had finished before I closed the solver window, so let's share the results. I'll jump into Fusion Team to visualize this, something we were unable to do in the past. The resultant body from the shape optimization looks as good here as it did in Fusion 360. But to be more formal and gain additional information, let's look at another way to share results, a report. We'll do this time with the accelerator shape optimization, which finished while we were in Fusion Team. One of the added benefits of creating a report will be found here, where it's reporting precisely how much the new version weighs versus the original, and how much of an improvement that was. Great stuff. But enough about simulation, let's fire it over to Bryce to talk about CAM improvements.
Finally, we have some updates to our CAM workspace. First, we have some functionality under our Fusion 360 previews to get into your hands early before it's ready for prime time. In this update, we have thrown a lot at the waterjet, laser, plasma cutting operations to get them ready for prime time. First, Give them a test out by going to the Preferences, then to your Preview section. Once activated, let's start by creating a setup. Now you won't have to hear me say water jet, laser cutting, and plasma cutting over and over because we renamed these operation tool types into one group called cutting. Also, the toolpath will be known as a 2D profile. With this change, we have also updated the tool library to include new tool types for water jet, laser cutters, and plasma cutters. Make sure to set up your tool library to meet your shop's equipment. For this operation, we will select a water jet tool. Now, I want to cut out all of these profiles on this flattened sheet metal design. Previously, I would have had to select all these contours manually. I can't even count how many clicks that would have taken me. Now watch this. I'm going to select the face and it will automatically select all the contours on that face. I even get the option to only choose outer loops, inner loops, or all loops. Now that was too easy. Within a single click, I was able to select all the contours needed to cut this complex flat pattern out. Last but not least, we are always adding and updating our CAM post library. Make sure to go to cam.autodesk.com/posts to check them out.
All right, guys, we hope you like what you saw. A lot of stuff in every workspace, but drawings takes the cake in this case.
Has to. You have custom tables, ordinate dimensions, and multi-sheet drawings.
Multi-sheet, everyone's been asking about that. Well, keep your eyes peeled. There's always more coming. Cheers.